Hello, everybody, and welcome again to another OpenShift Commons briefing. Today, we have another new OpenShift Commons member, Cybric. They've just recently joined, though they've been working on their integration with OpenShift for quite a while, not quite a while, but for a while, and they're going to tell us a little bit about that in a talk called Securing a DevOps OpenShift Pipeline. Andrei and Sergey, thank you very much for joining us today. I'm going to let you both introduce yourselves. The format for this, as always, is ask your questions in the chat. We'll have some live Q&A at the end, and hopefully we'll enter and have a great conversation at the end of this as well. So, Andrei, take it away and tell us a little bit about Cybric.
Great. Thank you, Diane. So I'm going to start with my introduction, then I'll pass it off to Sergey for his. I'm the VP of Engineering at Cybric. I've been with the company since July 2016. I am based in Boston, Massachusetts, where our company's headquarters. And my main focus is platform architecture. I'm working on building and expanding our ecosystem of partners. I'm very involved in the early customer experience part of the business. Prior to being at Cybric, I worked for a long time in financial services, where I primarily work with teams, small and large, on very complex systems, research, portfolio management, and analysis, electronic trading. I'm a certified Scrum Master, and I love working on complex systems and solving complex problems, sometimes with easy-to-use technology. Sergey, I'll let you introduce yourself as well.
Yeah, so my name is Sergey Bobrov, and I'm Director of Engineering at Cybric, and I'm with Cybric since February last year. And again, my main focus is on extending platform architecture, making sure we can satisfy evolving needs of our customers, and also as our platform targets like companies with the right variety requirements of and approaches, we making sure that like architecture platform supports like any cloud, any on-prem, or any combination of thereof solutions. So I was working on different things in the past, and actually quite excited to be part of the Cybric at this point.
Thank you. So let's talk a little bit about Cybric. I'm not sure if many of you know about us. We are a Boston-based startup, and our mission and our goal is to enable our customers to fully integrate and automate security throughout the development lifecycle. And that starts from the day a developer writes the first line of code and commits it to a code repository, through the build process, through a CI/CD pipeline, and also as applications are being deployed into non-production and eventually production environments. And our goal is to not only integrate and embed security into this process, but do so without a significant impact to the production environment or really to the developer's workflow. So we're looking for seamless integrations as much as possible. The reason we built this platform is because we've noticed that there are several challenges with the current approach to application security. These challenges range from the fact that traditionally many companies have that have adopted DevOps strategies and cultures still have a separation between DevOps and SecOps, and the security team is always separated, not just physically, but in many ways from the development team. So as a result, many applications are scanned late in the development process, sometimes just prior to going live or even after going in production in some cases. And that's usually done by a security team that doesn't have intimate knowledge of the applications that are being developed, doesn't have any involvement in the design of the applications. And usually issues that are found are just thrown back over the fence to the development team to fix. And that usually becomes a conflict with their priorities of delivering features and functionality and going live. So that usually creates a lot of friction in many cases. We also recognize that many of our customers and potential customers are already doing something about security. They have a number of tools in place. In many cases, they have combinations of both commercial and open source tools, and they are usually owned by different teams, different individuals, different groups altogether. And there isn't a lot of collaboration between those teams. And what they're missing out on is recognizing that there are both gaps and overlaps in the tooling. It's a very difficult to manage environment, and they're really not benefiting from that overall view of their entire security posture all in one place. And getting there usually requires a lot of manual work, Excel spreadsheets, data processing, and people. In many cases, the approach to security testing is periodic, sometimes infrequent. It's done based on application delivery schedules. It's done at certain points in the development or deployment process. And that tends to be expensive. It tends to be a mini project every time it happens, where people are pulled from their regular jobs in order to either participate or to react to issues that are being found. But in between scans, lots of things can happen. Vulnerabilities can get introduced. New vulnerabilities that have existed there all along maybe have been discovered and reported. And also, sometimes they don't get fixed in a timely manner. But the cost of fixing those vulnerabilities is reasonably high because developers or engineers need to switch context, try to figure out exactly the context in which these were introduced or found, and fix them as a mini project. Many times we notice that there is not just a learning curve from a development team's perspective in order to learn about development, about security tools, static analysis tools, composition analysis tools, but sometimes going through that curve and starting to take steps to scan their code and their build artifacts and their containers is disruptive to their development velocity, especially in organizations where they've taken an agile approach and they use Scrum methodologies. This becomes a disruption to that velocity. Ultimately, because this is not generally a comprehensive program or framework, companies are missing out on the visibility they can have at a high level, at a business ownership level, from a stakeholder perspective or from a C-level executive perspective, to truly understand their risk at an application and enterprise level, and they're missing out on a number of metrics and KPIs that they can have access to in order to improve their operations, to improve their risk, and to improve their processes overall. So what we do is we try to bring sensible solutions to many of these challenges, regardless of what kind of environment you have. So whether you are a small company that's just starting to build a platform, an application, or whether you are a large corporation with hundreds of thousands of developers and applications, there is a way you can adopt the Cybric platform to make it seamless for you to embed security into your software development lifecycle and ultimately reduce your risk from a cyber perspective. So some of the things that we do, and we'll talk about these in more detail a little bit later, is we enable customers to be proactive. And we talk about shifting left, which really means embedding security tools, processes, and best practices into the DevOps process. We provide a central administration component to the tools that you're using. We are not a scanning tool. We do not make scanning tools. We are a platform that's focusing on orchestration and automation that allows you to plug into it both open source and commercial tools that either you already have or that you'd like to introduce within your organization. And again, these range from static analysis tools to composition analysis to container security tools to dynamic scanning tools to automated pen testing and so on. So we make that process easy. We make it as seamless as possible. And we give you the ability to when appropriate, when possible, to provision, administer, and manage those tools. We make sure that we stay away of any breaking changes that those vendors are putting in place in order to really ensure that you don't feel the pain of that. But we also give you a unified, a single interface to interact with all these tools. So by simply specifying which tool you want to use and which configuration of the tool, you can interact with them the same way. So you don't have to learn about their specific APIs, workflows, and command line differences, and so on. I talk about seamless integration into the software development lifecycle, and we do that in a number of ways. We use sensible triggers as much as possible. We try to use webhooks at the repository level so that on commits we can get copies of the code and submit them for scanning or on pull requests. We try to add steps, sensible steps in your build pipeline so that at the end of the build process, the build artifacts, the output of the build process can be submitted for scanning as appropriate. As applications are being deployed by your deployment systems, we hook in at that level. So through either triggers or other sensible mechanisms, we can get notified of those actions and we can start scanning the newly deployed applications immediately. And we will talk in more detail about how we do this in an OpenShift environment, of course. Ultimately, we collect all the data from the various scanning tools. We bring into our platform and we make sense of it. We provide powerful analytics and metrics that you can leverage to get this high-level view of everything that's going on within your environment. So again, the approach, there are just a couple of components to our approach. Automation orchestration is our bread and butter. We automate the scans and we orchestrate the entire process. We integrate with a fair amount of scanning tools, both open source and commercial, and that ecosystem of integration is increasing practically every week. We provide you visibility and assurance, visibility into the vulnerabilities, the risk at the application level, any correlations and KPIs, and assurance that this is running on a continuous basis. It doesn't require people to execute manual commands. It allows you to institutionalize the tools and the frameworks that you use to scan your code and applications and environment. It allows you to ensure that this operates continuously and only get notified of specific relevant events that occur within that world. So let's talk a little bit about how this actually works. We're going to start off, as I said, with the developer writing code and committing it to a source control repository, whether it's GitHub, Bitbucket, GitHub Enterprise, SVN, it doesn't matter. At the end of the day, we integrate with many source control repositories. And again, we use, for the most part, tools like webhooks in order to get notified of specific actions of interest, like code commits, like pull requests, and things like that. And upon receiving those notifications, we will reach out to the respective code repositories. We will pull a copy of the code and submit it for scanning, either static application scanning or software composition analysis. And we will do so with one of the tools that we've already integrated with. We add, again, new integrations all the time. So if there's something you don't necessarily see on this list, this is just a representative sample. This is a list that's ever changing and ever growing. Beyond that initial setup, this does not require the developer to do anything specific, to take any specific steps in terms of manually having to submit their code for scanning. It simply works as a background task. They can certainly use our platform to get visibility into the results, but they can also get notified via email, via Slack, when any new issues are detected or any existing issues are remediated. We can also open tickets in their incident management system, whether they use Jira, whether they use ServiceNow or something else. We have the ability to open tickets in those systems and leverage their existing tools, their existing DevOps processes in order to get notifications of these new vulnerabilities that are being detected. Beyond that, there's typically a build process, whether that's with a tool like Jenkins or something else. We have the ability to integrate with most of these platforms through a generic add-in that's Docker-based. We can insert steps in those CI/CD pipelines at various stages. after the code checkout, again, we can insert a step to get a copy of that code and submit it for scanning. After the build process, we can take a copy of the build artifact, the jar files, the executables, DLLs, whatever it is, and submit those for scanning for binary analysis. And also, if that pipeline is used to deploy applications or to build containers, we can also scan the container images that are created. We can submit them for scanning with the appropriate tools, or we can run a dynamic scanning tool against the deployed instance of the application. So again, once those container images are built, whether they are put in an artifact or image repository like Docker Hub, Nexus, Artifactory, or whether they're pushed directly to an OpenShift container registry in your OpenShift environment, we're able to again immediately upon creation or publishing obtain those images and submit them for scanning with tools like Claire, Aqua, Twistlock, and so on. In all cases, the results are collected and they come back to our platform and they get processed and analyzed. And we'll talk in a minute about what are the things that we do with these results to maximize the value you can get from this information. Let's talk about the OpenShift environment for a minute. So our integration with OpenShift, as Diane mentioned at the beginning of this call, is a reasonably new addition to our suite of integrations. And the way we integrate with OpenShift is, again, following the same methodology as everything else. We try to provide a seamless integration to your non-production and production environments. As such, as Docker images are being staged, as they're being deployed and spun up as applications, as new routes are being made available as external endpoints, we have the ability to monitor for all those events in your OpenShift environment. And upon receiving those events, our platform will take the appropriate action to automatically create the target, the representation of the target in our platform, to set up the appropriate process, what we call security policies, in order to start scanning those with the tools of your choice. And we have the ability to automatically scan those as soon as the applications are being published, as soon as the routes are being created, or as soon as the images are being staged in the container registry. And during our demo, we will show you in detail about how this is achieved. So beyond, again, container images, just as I said now, once applications are being deployed, once those external routes are being published, we can launch one or more dynamic testing tools against those that can be launched either externally to test the routes as external, attack vectors, or internally inside those nodes, those OpenShift nodes, to provide a view of what the internal risks might be in this case. We have the ability to also scan the underlying infrastructure, whether it's running in a VMware environment, whether OpenShift has been deployed in a VMware environment, or whether it's been deployed as on top of a cloud provider. We have the ability to look at the settings and the configurations of those environments, as well as those clouds, of the networks, because in our opinion, all those areas can pose a risk, can cause risks to your application environment. If the question you're trying to answer is truly, what are the risks to my application, my enterprise? Those risks can come from a variety of places. They can come from the code that's being written. They can come from the open source libraries or components or frameworks that you're embedding or referencing in your code. They can come from the way you're building container images and the base operating systems you're using for those images. They can come from your configurations of your OpenShift, AWS, Azure, VMware environments. They can come from the way you build the underlying hosts on which you're running everything else, and the way those are getting exposed and secured and configured. So our goal is to give you that comprehensive view of truly your entire application stack and your entire enterprise by leveraging the best tools for the job by leveraging integrations with your favorite static analysis, composition analysis, container security, dynamic testing tools, and by bringing it all together to make sense of it. And we do so primarily through our dashboards and our reporting infrastructure. And I'm going to take a couple of minutes to talk about that as well. So we take an interesting approach to analytics. We take a multi-tiered approach where, as a first step, we collect the data from all the scanning tools. We load it into our platform, and we start normalizing the data. We do so because all these scanning tools provide it in different formats at different levels of granularity and so on. So we've tried to normalize it and look at it on the same basis. We then help you better classify the data and overlay your own perspective on top of it. You can specify what's important to you, what's not important, what are known false positives, what are vulnerabilities that can be treated with higher or lower priority that indicated by the various scanning tool vendors. We also help you deduplicate data within a single scanning tool. In many cases, these tools provide all the instances of the issues they find as individual vulnerabilities. But in recognizing that if you have 30 different instances of a SQL injection problem in your code that are really identical, but in just 30 different places, you really need to fix all of them in order for that not to be an exploitable vulnerability, a problem. So we consolidate that into a single issue, keeping pointers to all the 30 locations in code and allow you to fix all of them. But we would only send a single notification, create a single vulnerability issue, or report it as a single JIRA ticket in this case. We also recognize that in your tool chain, you may have overlapping coverage. You may have multiple tools that detect the same issue. So we will consolidate the data and create composites of vulnerabilities, again, keeping track of the individual sources, but we report that to you as a single vulnerability against your application stack, not as output from the various scanning tools. Beyond that, because we keep track of your entire application stack, here's the code, here's the build, here are the containers that are being created as part of this application stack. Here are the actual deployed components, the web server, the database, the application server. Here is the exposed routes. Here's the configuration of the underlying environment. We can correlate results, vulnerabilities that are discovered across that entire ecosystem. We can correlate findings from static and dynamic issues and really highlight whether any of the statically defined issues or results from composition analysis are exploitable by telling you that there was an actual exploit executed against that running instance of the application. So those are real issues regardless of the severity that they were reported with. We can also use this technique to tell you what are the likely root causes of the exploits that are being observed against the running instance of the application. Ultimately, we help you understand the application risk by giving you a risk score that we calculate based on a number of different factors. And we can roll that up into application groups or at the enterprise level. And we can give you an indication of what are the biggest risk areas. We can effectively show you what contributes the most to that risk, and that can help you create a roadmap for minimizing that risk across your environment. I'm going to stop here. Next, we have a short demo, and I would like to ask Sergey to spend a couple of minutes on the demo.
Yeah, can you see my screen, guys?
Yes.
Okay, perfect. Yeah, so I'm going to briefly introduce Cybric platform and basically showcase how the things that Andrei was talking about are happening from a user perspective. And so what we're looking at on this screen is, first of all, to be able to set up like communication with a specific environment with a like code repositories, source code controls repositories, things like OpenShift, cloud environments. We need an integration from a Cybric environment, which is basically the way for our platform to know the way within this specific theme, right? And in this case, in case of OpenShift, so we define.
I'm not seeing your screen. Are you currently sharing?
I am. Dan, can you see my screen?
Yes, I can see your screen.
Okay. Okay.
Great.
Yeah, so we are talking about two types of OpenShift integrations. One is related to what we call external, is related to publicly exposed routes within the OpenShift platform, and internal is the applications which are actually instances of the specific containers running within the OpenShift environment. And the way to set up it in the Cybric is very simple. So you can specify type of platform you're going after. You have to provide like some connections parameters, like your URL to connect to and the token. And then really Cybric takes it from there. As soon as you create an integration, and so what happens within an OpenShift environment, we deploy for each integration created in Cybric, we deploy a special service called Watcher. And the main idea behind this Watcher is to basically monitor any changes that happen within your OpenShift environment and report those changes back to Cybric. So Cybric can like correlate those results against what was there before and take any actions. So if you deploy a new application, it will scan with appropriate tools. If you modify the existing one, it run the same in policy again. And whatever happens within your OpenShift environment, you continuously get in the picture of like ever-evolving security vulnerabilities which were discovered during the scanning process. So basically, once you create this integration from a Cybric platform, run discovery within this environment, and what you can see here is the applications deployed within my OpenShift environment, which is demo environment, and each application is basically container deployed as one or maybe multiple pods within a specific namespace. And so those discovery results converted to things we call targets. And so these are individual instances of what exists within your environment. Could be repositories, containers, hosts. It really depends on the specific of the environment. And then, as Andrei was talking about, we have many integrations with the existing commercial and open source security providers. So we able to run a big variety of scans, and this number of integrations is ever evolving. So you can go against your repositories, you can run static code analysis, dynamic code analysis, and a lot of different things. And within each product, there are multiple, possible to exist multiple configurations. Like, for example, for Nmap, network vulnerabilities, you can just do network mapping, or you can do more like robust security vulnerability detections and stuff like that. So you can, within each product, you also have like wide variety of typical configurations, which could be specific to your environment. Or like if you're using the dynamic application tool, you can basically upload the entire script to go against your environment. So in this case, so what's happening within the Cybric platform, we create this mapping of integration to the selected scenarios which you would like to apply against it. And what this mapping means, it means every time, so there's a policy group for OpenShift internal environment. It basically, so this mapping creates a link between OpenShift integration and the Nmap scenario, and then everything what exists within OpenShift environment gets scanned with Nmap, and vulnerabilities get reported to Cybric. And with that, so with the application Watcher deployed, what I can do here is I can deploy a new image in a Cybric test namespace, which is monitored by Cybric in this case. So I deployed an application, and what's really happening under the hood is what should get notified of the changes within the environment. It runs a discovery within this environment and reports results back to Cybric to be able to see what has changed, if everything was edited, modified, removed, and that case actually triggers change in targets which exist in the Cybric platform, and that in turn results in a in this case we create new policy, and as we refresh here, as you can see here, there's new target, the new policy created for that specific integration, and it's currently running. Basically, it will take around 1.5 minutes to finish, and once it finishes, we'll get results back to Cybric, and you'll be able to see it on individual target level, so you can see, for example, issues which were reported here, and this is the presentation of what Andrei was talking about. This is a Cybric synthetic issue, which is already normalized.
Basically, what we're showing here is that we're able to automatically recognize. Let me just take over the presentation. So we're able to automatically recognize that a new application was deployed. We automatically start scanning it, and then we can show results of those scans. So in this case, I forget which one exactly we were looking at, but this is an example of an application that has one policy configured against it. In this case, it was able to find a critical vulnerability. You can see the details of the vulnerability, as well as all the specific details that Nmap was able to provide in this case. And you can look at this across all the targets, and as you build application entities that contain multiple targets, you can see an aggregated view, you can see correlations, and you can see additional metrics around this. So that's where we're going. I see, are there any questions on any of this so far?
No, right now we don't have any questions in the chat, but I have a question for you, and Sergey, don't really worry about the coughing. I can edit that out. The question this is amazing because it's so comprehensive and it pulls in stuff from like every aspect of the security workflow. What I'm curious about is, what is Cybric built on? Where are you running Cybric? Okay.
That's a good question. So our default offering is a multi-tenant a platform that we offer as a software as a service, and we're running in AWS. That being said, we have the ability to use a Docker-based agent that lives within the customer's environment that's effectively a thin client that's using our REST APIs that has access to the customer's environment. So through that agent, we can reach both the internal repositories and build pipelines, as well as the internally deployed applications, OpenShift environments, whatever the case may be. And then we can also perform scans from the outside, whether they're using a SaaS-based or a cloud-based source control repository like GitHub or Bitbucket, or whether we need to perform dynamic scans of their external endpoints. So we're basically AWS based at this point.
And I think Sergey said offline that you were also running on Kubernetes.
Yes, that's right. So our underlying architecture is based on microservices, which are built as Docker containers, and that's deployed in Kubernetes. Yeah. So we are running, managed Kubernetes in AWS. Now that is our default offering. We also offer this for our enterprise customers as a private instance of the platform that they can deploy anywhere Kubernetes or OpenShift runs. So whether it's on bare metal in a virtualized environment like VMware or ESX, or whether they're running in a cloud in managed Kubernetes like Azure, AWS, or Google Cloud.
Really covers all of the aspects of the hybrid clouds that we're seeing people starting to deploy and actually having deployed. So it's quite useful to have something that runs pretty much everywhere they are. So
yeah, and we're starting to see more interest in our private instances, especially from the larger customers and the ones that have certain needs for running environments inside their ecosystem.
Great. I don't know if Sergey is back with us yet.
I am.
Yeah. Is there anything else that you'd like to add to the demonstration part or cover that?
No, I think that was pretty much it. I was going for the last screen, and so that's I think that covers the use case. So there was last step to be able to show how issues like reported by scanning tools end up being back in Cybric. That's it.
Oh. So Andrei, if you can put up your last slide so people know how to get a hold of you guys if they have questions, that would be great. And I'm not seeing any of the folks who are listening in asking any questions, so you must have done a great job doing the setup and the demonstration. So that's wonderful. And we will ask that you send me the slides, and we'll post the slides and the video shortly up on YouTube.
Great. Well, thank you, Diane, for hosting, and thanks everyone for attending.
Thank you.